Now we will see classification of the materials. Classification of materials. This can be done based on conductivity, or this can also be done based on energy band diagram. Okay. First we will see what is the classification of the materials based on conductivity. So here three types are there. One is conductors, second one is insulators, and third one is semiconductors. So when you provide the external energy to one particular material, if that material is providing large amount of the conductivity, sigma is the conductivity if it is very larger than 1. That means it is approximately equal to infinity. Then we can tell that material is the conductor. When you provide the external energy to the material, if it is not able to provide any amount of the conductivity, then you can tell that is the inductor. So conductivity is almost 0. If the conductivity is very high, then you can tell that is a conductor. If the conductivity is very less, you can treat that material like a insulator. What about semiconductor? In this particular semiconductor, when you provide the external energy, you will not get conductivity as infinity, you will not conductivity as 0. It is in between these two. Okay. So you can tell that type of material is a semiconductor. Examples I am going to give here. So conductor means examples are metals like silver, copper, like this you can take. Okay. And what are the examples of the insulator is nothing but wood you can take, paper you can take, diamond you can take. These are the examples of the insulator. What about semiconductor examples means already we have seen those are silicon and germanium. Okay. So even though large amount of conductivity is there, it is not coming under the electronic device. We cannot able to make the electronic device using the conductors. We cannot make electronic devices using the insulators, but we can make electronic devices using the semiconductors. Okay, if you have high amount of conductivity or if you have very low amount of conductivity, the fabrication or the manufacturing of the electronic devices is not possible. It should be in between these two. Then those electronic devices can be using as the amplifiers, those electronic devices can be using as the switches. The switching operation is very important. The switching operation can be done when the conductivity is in between these two. You are going to understand all these things in detail when you're going to see about the PN junction diode itself. Okay. So those things we are going to see anyhow. Now coming to another way of classification of the materials that is based on the energy band diagram. So in the energy band diagram, we know what is valency band, what is conduction band, what is forbidden gap. Forbidden gap is given by Eg. So exactly we can tell based on that Eg value, you can able to classify the materials like this. Again, the same classification only, that is conductors, insulators and semiconductors only. But based on this Eg value, you can able to tell the material is coming under conductor case or insulator case or semiconductor case. So generally energy band diagram is having three bands like this. On y-axis energy in electron volts is there, it is conduction band, it is a energy gap and it is a valency band. Okay, so when the valency band and conduction band both are overlapped, okay, both are overlapped, then so conduction band is up to here and valency band is up to here. So this is conduction band and this is valency band. Then it is nothing but we can tell it is a conductor. That means what is the energy gap here? Eg is equal to how much you can able to tell? What are the units of the energy gap? Electron volts. So what is the value we can tell here? I will tell. Next, in case of the insulator, definitely we have to maintain certain gap in between the valency band and the conduction band. Okay, so the formula is actually here EV, here EC available. So certain gap is there in between these two. So here also we need to tell the value of EG. EG is equal to certain electron volts. But when you coming to this semiconductor, I have drawn the diagram like this. So by seeing the diagrams, we need to tell it is related to semiconductor or insulator or conductor. Here also energy gap is given by certain electron volts. Just you observe these two diagrams and tell what is a notable thing we can able to do. The gap in between EC and EV is large here. The gap in between EC and EV is somewhat smaller. That is what we need to observe. And we need to comment on energy gap only in electron volts. What about here? Both are overlapped. That means here there is no energy gap. There is no energy gap in case of the conductor. So Eg is equal to 0 electron volts. Then we can tell that material is nothing but conductor. What about this case? When Eg is greater than 6 electron volts or 6 electron volts, then we can treat that particular material like an insulator. And when you take it is approximately 1 electron volt. When you have energy gap is 1 electron volt lesser than the 6 electron volts and greater than the 0 electron volts. So when the energy gap is in between the insulator energy gap and conducting energy gap, then we can tell that is a semiconductor. Okay, this is for semiconductor. This is what we need. Our subject is based on the semiconductors only, not on the conductors, not on the insulators. Okay. So it is about the semiconductors. So this is another way of classification. It is based on energy gap. And here we have classified the materials based on the conductivity when you provide the external energy. I am telling while defining the conductor, insulator and semiconductor in this way, I have given the ending point is by providing the external energy. For example, this is the insulator. How the definition is valid here? If it is a metal also, if it is a copper also, you cannot have the current in this one. If it is copper material, do you have current in this one? No. You will get the current when you provide the battery to this one. That's why you need to tell the material is said to be conductor when its conductivity is very high when you provide the external energy. Even though it is copper, when you don't provide the external battery, you will not get current through this one. So in the definition, you should include by providing the external energy. So when you provide the external energy, if you get a large amount of conductivity, that it can be treating like a conductor. When you provide the external energy, if you don't get any conductivity, that is called insulator. When you provide the external energy, when you get the conductivity in between these two, then you can tell that is a semiconductor. Now coming to this one. When Eg is 0, conductor. When Eg is around 6 electron volts, that is insulator. When Eg is around 1 electron volt, that is semiconductor. When you have this 6 electron volts, what is the meaning of that one? Even though you are applying the external energy, if you provide the external energy, in case of the conductor, all the electrons easily will jump into the conduction band. Here, what will happen? If you provide the external energy so much also, the electrons available in the valency band cannot jump into conduction band. It is not at all possible. That's why you will not get current. Current is not because of the movement of the valence electrons. Current is because of the movement of the free electrons. These valence electrons should go to conduction band and then move. Then only current is possible. Then only conduction is possible. Then only conductivity will be available. Okay. So when you have 6 electron volts as the energy gap, you will not get the free electrons. You will not get jumping of the valence electrons into the conduction band. That's why free electrons are not possible in this particular case. But when you take this semiconductor with certain amount of external energy, with certain amount of the external energy, you can able to tell these valence electrons will jump into the conduction band and become the free electrons. And because of those free electrons, you will get the current. Okay. This is what you need to understand regarding the energy band diagrams of the different materials like a conductor, insulator and semiconductor. Okay. Then you need to know about hole. This is valency band, this is conduction band. Certain energy levels are there in the valency band, and from the already discussed theory, you have understood that same number of energy levels must be available in the conduction band also. Energy is measured in electron volts. Here I am going to discuss about the concept of hole. Okay, so you see this one very carefully. As I said earlier, each energy level is for one electron only. So here one electron is there, here another electron is there, here another electron is there, here another electron is there, here one more electron is there. Okay, at T is equal to 0 degrees Kelvin. All these electrons are in valency band only. Okay, all electrons are in valency band only. At this moment, you will not get any current. If you want current, these electrons should go to conduction band. Then only current is possible. Okay. So, because all the electrons are available in the valency band, those electrons are called bonded electrons. So that we will not get any current. Current is equal to 0 or conductivity is equal to 0. Okay. So, this is possible at T is equal to 0 degrees Kelvin. So, no current means it is acting like an insulator. So, this is very important point. So, at T is equal to 0 degrees Kelvin, it is silicon only. It is silicon material only. Silicon is semiconductor only. Okay. But at T is equal to 0 degrees Kelvin, since you are not getting any current, you can treat this silicon or germanium like insulators. Don't confuse here. Here I am saying silicon and germanium are insulators, are acting like an insulator because these are not providing the current. This is possible when you apply T is equal to 0 degrees Kelvin. Okay, I will explain using this also. It is copper. Okay, you take original copper, but do you get current in this one? No. Why? You did not provide the external energy. You did not provide the external thermal energy, or you did not provide the external battery electrical energy. Since we did not apply any external energy, even though it is copper, no current is flowing through this one. Okay, electron movement is not available here. So that to get that electron movement, extra energy is required. To get electron movement, you need to apply the thermal energy. At T is equal to 300 degrees Kelvin at room temperature, then electrons will go to conduction band and become the free electrons. So that current is possible, conductivity is possible. Now this is like acting like a semiconductor. Okay. So these are the very important points you need to understand. Here very important point is semiconductors can be treating like insulators when you take the temperature is equal to 0 degrees Kelvin. That is a very important point. Okay. Then now exactly what is this whole concept we will see. As I said earlier, when you don't apply any temperature, all the electrons will be here only. And here certain energy levels we have taken, but no electron is available in this particular energy levels, that is conduction band. Now you start increasing the temperature. When you start increasing the temperature, these electrons will go to this energy levels of the conduction band. Okay, now these electrons are called free electrons. Here electrons are there. These electrons are called free electrons. So that current is possible. What about the vacant spaces available in the energy levels here? In the valency band, it is a group of the energy levels, and each energy level is containing only one electron. Because of the temperature increment, this electron is now jumping into the conduction band. So here vacant position has been created. Vacant position. All these are vacant positions are there. These vacant positions are called holes. Okay. Holes movement is also possible in the valency band. Because of the holes movement also you will get the current. Because of the free electron movement also you will get current. So in the semiconductor, current is due to both free electrons and holes. It is very much different compared to the conductor. So in case of the conductor or metal, conductors, so only free electrons are possible. Only free electrons are possible. No concept of hole. No concept of hole in case of the conductor. But if you take semiconductor, current is due to both free electrons and hole. And what is hole? Hole is nothing but vacant space in valency band or vacant space in covalent bond. What is this one? Covalent bond is available among the silicon atoms of the silicon crystalline material. So whether it is a valency band or covalent bond, we can able to treat like a same thing. So that vacant space is called hole. Now, what is the charge of the free electron? Is it positive or negative? Negative. Charge of free electron is negative. Charge of hole is positive. How can you tell like this? Means again we have to take energy band diagram. For example, here one energy level I have taken. This is a bonded electron in the initial stage. Okay, then you apply the temperature. Temperature you are increasing. Then what will happen? Here hole has been created. This is jumping into conduction band. This electron is now free electron. Now see careful. When you take the temperature 0 degrees Kelvin, this electron is available in the valency band only. It is called a bonded electron. Okay. But when you increase the temperature up to 300 degrees Kelvin, this bonded electron is going to the conduction band and become the free electron. And here vacant space has been created, that is called hole. Now the discussion is about what is the polarity of this particular hole. See carefully. Here previously electron is there. Electron is of negative charge. So previously here negative charge is available. Now here lack of the negative charge is there. Lack of the negative charge is nothing but it is the positive charge. So in this way we can able to tell the explanation for the polarity of the hole. Electron is negative only, but hole is positive. That is what you need to understand. Okay. Then coming to definition of current. Definition of current. When I say what is the current is nothing but you need to ask whether you need to define the current in conductor or you need to define the current in semiconductor, because the definition is different in these two. You know that current is nothing but flow of the electrons. So it is valid in case of the conductors only, like silver, copper. What is the current means? When electrons are flowing, you can able to tell current is possible. But when you deal with a semiconductor, current is not just because of the electrons. Current is because of the holes also. So we have two types of the charge carriers. We have two types of charge carriers in the semiconductor. But in case of the conductor, only one type of charge carrier. Here, only one type of charge carrier. In case of conductor, we have only one type of charge carrier, that is electron. But in case of semiconductor, we have two types of the charge carriers. Those are free electrons with the negative charge and holes with the positive charge. Negative charge and positive charge. Okay. So here current is due to these two. Here current is due to only free electrons. So when you say current is the flow of electrons, means the definition is not valid in case of the semiconductors. So how to tell the definition of the current in case of the semiconductor? Current is flow of free electrons and current is flow of holes also. So combinedly we can tell current is flow of charge carriers. Flow of charge carriers. This definition is valid for both conductor and semiconductor. So current is the flow of the charge carriers. If you are dealing with conductor, the charge carrier is a free electron. If you are dealing with semiconductor, then that charge carrier is nothing but free electrons and holes also. Like this, you can able to define the current.